They're incredible engineers. They create their own cement and build their seawalls. Like, they stick together, literally. They protect communities from storm surge, and they clean the water. Oysters are really incredible in many ways, and they benefit people in many, many, many ways, and we're just trying to uncover one piece of that puzzle. Well, North Carolina is heavily reliant on the oyster aquaculture industry. There's people that eat oysters, there's people that are willing to pay money for oysters, there's farmers that grow oysters, and then there's us, and we study oysters and the functions that they perform, specifically functions that relate to maintaining water quality. Our group was the first one to measure oyster-mediated denitrification. They've been doing this oyster work for decades, years and years and years, and there were many different cohorts of grad students and faculty collaborators that have contributed to this work.
So our lab is the Peeler Lab, and we have been doing research for about 25 years and focused on oysters for about 20 years. And we're fortunate to be among the leaders in the field of trying to understand how oysters remove nitrogen. We have 85% fewer oyster reefs than we did at their peak. So two challenges: too much nitrogen and not enough oyster reefs are creating a disconnect here in a way that we could be helping solve this problem.
Anne Smiley is a postdoctoral researcher at UNC's Institute for the Environment. In this study, UNC researchers found another way oysters help the environment, through a nitrogen removal process called burial.
That nitrogen burial paper of Anne's is really exciting. It includes a fisheries ecologist, a geologist, the original ecologist who built those reefs. I think this study is done in a way that will allow us to immediately apply it to creating solutions.
Oyster reefs, they're like incredibly resilient, and their ability to capture and produce their own sediments and then retain them allow them to build up vertically as water levels rise. And as they do that, they're burying all kinds of stuff underneath them, including nitrogen. Fringe reefs like this that are on a ramp right next to a salt marsh bury nitrogen differently than a reef that's standalone out on a sand flat that's like a patch and a mound. If you're gonna design a restored reef to maintain water quality or to reduce algal blooms, certain design should be prioritized over another.
We have a pretty comprehensive understanding. There's always more to learn, but I think we're at a time now where we can begin to apply this understanding to problem solving. And there are certainly plenty of challenges to meet.
To get a real comprehensive, holistic picture of these systems, I think is really, it's astounding, it's amazing. I feel like really grateful to be a part of it.